Hello guys, in this video I'm going to be showing you guys how to solve problems involving permutations and combinations. And to help me show you guys these problems, I'm going to be using a problem from this textbook, Probability and Statistics for Engineering and the Science. And I'm going to be using problem 30 from section 2.3. If you're using the same textbook and you're having hard time with this problem, then this video is for you. Now, before I continue, please like my video, comment below, share it, and subscribe. And also don't forget to read the description below for more information about the video, the timestamps, and how to support me. Alright guys, because we're going to be doing permutation and combination using the same problem here, be sure to use the timestamps located in the description below to skip around. And also feel free to fast forward this video, or change the speed of the video under the settings of YouTube. Alright, so to just give you a heads up, the first problem is going to be permutation. The others are also going to be combinations, but in a different way, different ways. But I think this problem will be, doing this problem will be a good problem to show you guys the difference between, permutation and combination. The important part of permutation and combination, the difference between them, is really that the permutation is whenever you're doing the order is important. You're trying to find ways, how many ways something can be done if the order is important. And combination is the same thing, how many ways you can do something, but the order is not important. And one of the randomly selected is the key word here. Now be careful, because sometimes they don't use these keywords straightforward or randomly select. They might use the word for example, they might say, oh, the order is not important. Same thing. And the same thing with permutation. The order is important, or they must mention, I would like to know which is the first one, the second one, and the third one. That means also the same thing. The order is important. Okay? So let me go ahead and erase this. So we're going to start doing problem A. There we go. Alright, so for problem A, and actually let me read the question itself first. A friend of mine is giving a dinner party. His current wine supply includes 8 bottles of zinfandel, 10 of merlot, 12 of cabernet. He only drinks red wine. That information is, so far, it seems that this is extra information. I think they're only doing it just to have it like a complete sentence or a complete place of thought. Because you might say, hey, what happened? What is it? Red wine? White wine? No. All from different wineries. Alright. So please don't get confused with additional information. Sometimes they throw those in there just to have just to make a complete sentence of something. Alright, so always write down what they're giving us. 8. And also professors like these things. They want to, they like you making a list. Also, when you answer what they are, when you're answering these questions, it's always to give as much details as possible. More details is good. And also have the total. This gives us 30. So that's the total. In case we all know in case they want us to find something, and chances are, because you're dealing with probabilities, the total is needed. Okay. Now in permutation, the notation goes as follows. In this textbook, they do it like this: K, comma, N. In other textbooks, is P, N up here, and K here. And also in other textbooks, they do it N, R. So some uses the R, others use the K. It means the same thing. Please don't get confused with those, okay? And the permutation has the following formula. I'm going to use the R because I've been using the R for so long. I'm used to it. For some reason, it's hard for me to go back to the K sometimes, right? So it means N factorial, N minus R factorial, where N represents the number of sample and the R, also known as the K, represents the subset of that sample size. In our case, right here, you want 3 bottles, so that will be your R. So these will be your N, depending on the question, and your R is your 3. So it will look like this: P, 8, and 3, and then we have 8 factorial over 8 minus 3 factorial, which is the same thing. I'm going to write down here: 1 times 2 times 3 times 4 times 5, 6, 7, 8. That's what factorial represents. And the one with 5, so be 1 times 2 times 3 times 4 times 5. Now, of course, you can multiply the top one, multiply the bottom one, and divide them. Or, if you notice that there's some, because of the properties of multiplication, this will cancel, these. Whatever makes you feel comfortable, okay? At the bottom, it's going to become 1. The top one, 6 times 7 times 8, that gives us 336. So use the calculations to be sure here. 6 times 7 times 8 give us that. See? Which at the end, so your answer for letter A is 336. There's 336 ways that we can do this. So if you want to answer this as a complete sentence, it will say something like, my friend can serve the 3 bottles of zinfandel 336 many ways. Yeah, he can do this in 336 ways. Now, for the calculator, if you want to use the permutation, and again, feel free to comment below if you want me to do these videos showing you StatCrunch, or if you prefer Excel, or you prefer the calculator, either the TID4 or the TID9. In this video, I'm going to be showing you guys using the calculator and Excel at the same time. But just a quick Excel, nothing deep. All right, so for the calculator, we will go to math, go to the right where it says probability, and see right here they also have the option for the factorial. And here's where you're going to find your option 2 in this case is for the permutation. So if I go to option 2, there goes my permutation. Now, be careful, because before you do that, we need to type in the number 8. The number 8 is N, comes in first. So we do, let me write down here. Let me change the color. All right. So for the calculator, it looks like this: NPR. So it's going to be 8P3. So we're going to do 8 stat to the right, option 2, and then the 3 and enter. There it goes, 336. So that's how you do it, the permutation for this problem, okay? Now for Excel, I have my Excel right here. Oops, I didn't mean to do that, sorry. My Excel right here on the left side. And let me see, yeah, okay, that's good. And this is how you're gonna be doing the permutation, okay? We're gonna do well, first select the cell where you want the answers to be displaying. We're gonna hit the equal sign, then we're gonna hit the P. Whenever you hit the equal sign for an Excel, that's like a code to tell Excel that, hey, I'm gonna write some sort of a formula. And when you hit P, it's gonna give you everything, all the commands that has the P. As you can see in the bottom right here, we have permute and permutation A. For this one, we're going to choose this one right here. We'll click here, double click, and it's going to come out right here, as you guys can see with the parentheses. Okay? The first number is going to be the number 8, or the N, the number of samples. And you can tell right there, in the bottom it says number, and it says number chosen. So 8, comma, number chosen is the how many you're choosing from that sample, your subset. In this case is 3. Close parentheses and enter, and there it goes. And that's how you do the permutation. And for the combination, we're going to be doing the same thing. I'll show you, of course, when that comes up. Actually, don't save. Yeah, all right. So that's for that problem. Okay. All right, guys. Let's go into part B now. So the keyword here, which I already underlined it, is if 6 bottles. So they're giving us 6 bottles of wine are to be randomly selected. That's another keyword from the 30 for serving, and that's the other keyword. Unlike the part A, they use the order is important, but whenever they mention randomly selected, the order is not important, and they talk about 30 for serving. That means they talk about the whole total 30 bottles, and that is why it's always good to write down the total down here, so we'll know what they talk about. Okay, and let's see what else. And then yes, and now how many ways are there to do this? So you're looking for different ways, different combination of where the order is not important. Okay, and when there's different combination where the order is not important, we do combination. All right, so the textbook uses N and K. Some professors, other textbooks use N and R. Here I have N and R. So this all means the same thing. This is the formula for the whole thing. Here, as you can see, they use the formula uses part of permutation where the order is important. However, when they as you can see down here, we have a K factorial. That's what the order is not important gets involved. Anyway, so here's the formula. Here's the notation. Let me go ahead and plug in the numbers. Okay, so this is going to give us the 30, which is the number of samples, and the 6, which is the subset. So if we do 30 factorial all over 6 factorial, 30 minus 6 factorial. Okay. (30 minus 6 is 24 factorial. Okay. And of course, like I mentioned before, and as in part A, such as part A, factorial is when you would do as follow: 1 times 2 times 3 times 4, all the way to 30. And the same thing with the bottom one. 1 times 2 times 3 and all the way to 6. And then times to 1 times 2 times 3 all the way to 24. Oops, 24. Okay, let me just, okay. Now, of course, we can do this in the calculator. So let's go ahead and take out the TI-84. All right. So I'm going to turn this, it's already on. So we're going to do math. Up going to the right, which is probability. And we're going to do number 3. Either press the 3 or go down to 3 and press enter. Now be careful, because when you press enter, which I don't know why, I'm sorry about this, I keep forgetting, I need to plug in the number that represents n, in this case 30 first. So let's try this again. This 30, math, probability, option 3, and then the 6, enter. Okay, there it goes. So that's the answer for this one. So for question letter B is 593775. So that's how many ways, how many combinations you can do when you have 6 bottles of wine from 30 and 30 servings. Okay, there it goes. All right. Okay, now let's go ahead and do this in Excel. I already have my little Excel right here open up. Just like do this. We just select any cell where you want the value to be displayed. We do the equal sign, the code COM, and as you can see, we have 3 options here. We'll do the first one in this case, combine with the N, double click, and then we're going to do 30, representing N, number of sample, and 6 representing the numbers that we're going to be choosing from that sample, and enter. As you can see, get the same answer. Okay, so that's the difference between permutation and combination. One is with the orders important. Let me make this bigger. Zoom in a bit here. The order is important right here, and the other one when the order is not important. In this case, they use the words, the keywords randomly selected. Sometimes we even mention, they will just say order is not important. All right. Okay. Now let's go ahead and do part C. Part C is also combination, but this one is a little bit more trickier because combination in this case is going to be used a little bit different. Part A and part B, they were pretty much straightforward permutation and combination. But part C, we need to do some additional steps. So let's go and read part C. Part C says if 6 bottles, okay, are randomly selected, again that's the keyword for combination, how many ways are there obtained? So how many ways can we obtain? Alright, so as you can see, it's going to be similar, pretty much similar to part B. 2 bottles, okay. But here when things it changes. Instead of having 2 bottles for the whole serving, they want 2 bottles of each variety. That means 2 bottles from zinfandel, 2 for merlot, 2 for cabernet. Since they want obtain 2 from each variety, to obtain 2 from each variety, we need to combine them together. And in this case, we're going to combine them using multiplication. So it will look like this. We have the N will be 8. I'm doing zinfandel, by the way. Actually, let me do it up here. I think it'll be better organized if I do up here. So we do C 8 2, C 10 2, and then 12 combination 2. And then I'm going to multiply all these together. Okay? You can do it side by side if you want to, but I thought this would have been a little bit more organized. Okay? So when you multiply these together, the calculator, now of course you can do them each of them individually, but it takes a while. It will take a while. Now using the TI calculator, we'll do as follows. Let me zoom in. So 8 math option 3 2, and now just to keep things safe, we can do we can put all them together at one line, and then do the multiplication like so. But sometimes when the equation gets too big, we might need parentheses. So just to keep it safe, and it's just unless you're really comfortable with your calculator, go ahead. But just to keep it safe, I'm gonna put it separately. So first we'll do the first one. That gave me a 28. Okay. Then I'm gonna do the second one. 2. That gave me 45. The third one, cabernet, 12. Combination 2. That gave me 66. So we have 28 times 45 times 66. So there it goes. So the total is 8316. So 0. So 83,160 ways. All right. Okay. All right, guys. Let's go ahead now and do part. We'll probably do in D. Okay. All right. So keywords here. Let's read this problem. It says if 6 bottles are randomly selected. Okay. So that combination. What is the probability? Now, there's something new here. Probability. And from previous chapters or classes, the probability equals the number of success over the number of overall number of samples. So that's gonna get involved there. They want to find the probability, not the combination by itself, like up here, and part C and B. And this results in 2 bottles. So we have 2 bottles of each variety being chosen. So here's where we have a mix of both combination and probability. So here's what we're gonna do. We're gonna need to find first the combination of all of them for 2 bottles for each. So we have a combination choosing 2 for the zinfandel times, just like the previous problem C, and then we have 10 combination choosing 2 for merlot times 12 choosing 2 for cabernet, all over, and we divide this by the total number of 3 choosing 6, which is right here. And we divide because we want to find the probability. There's the success, what we're choosing, all over what the total we want. Okay? So we're going to do this really quick in the calculator. Do 8 2 times 10 2 times 12 2. And then we're going to do divide by. Well, that is going to grab the answer from the previous problem that we solved, and they're going to divide it by. And we're going to do, just to keep it simple, let's put 30. And 6. I wonder if this will work like that. Yeah, okay, good. Alright, so answer is 0.14, 0.14. Okay. Okay, let's go and now to do part E. And part E says, let me go ahead and get my pen here. If 6 bottles, alright, 6 are randomly selected, so that would tell us this combination. What is the probability that all of them are the same variety? So probability, again, we're going to be using probability, same variety. So we have all of them. So for them to be the same variety or same of anything, we are going to be using combination, but with the plus. We're going to be adding them up together. The difference between the adding and the multiplication is that, let's see, in part D it says results in 12 of each. Okay, each variety being chosen, and this one, all of them are at the same variety. So this one, each of them being chosen, and this one there. So you can look at it as a Venn diagram. Part D, let me make a different color. Part D, if you have bad, then let me try this again. If you think of it as a Venn diagram, for part D, for example, it says probability that each variable being chosen. So for each of them being chosen, we can do, we highlight in the middle part here, and that's your union, and that's where we do the intersections, and that's when we do multiplication. However, here's when it says all of them are the same variety. So we will highlighting this out here. So we want the probability if they're going to end up using this one only, or this one, or this one. In this case, they want to know if we're going to be choosing this one, this right here in the middle. And here's when we do the ORs. And when we do the ORs with the union, that's where then we are using we adding them up. Okay. All right, let's go and do that. Let me go ahead and write this down. So we have the probability of the success over the number of samples. And in our case, since we're going to be doing as the same variety, we will do addition. So we'll have 8 combination 2, choose 2 plus 10 combination 2 plus 12 combination 2, and then we have 30 combination 6. Okay. All right. So that'll be for that one. So now I'm going to go to my calculator. And since I'm here in the calculator, let me show you a little trick. Hopefully you guys will be able to catch up here. I'm going to go ahead up here, go up and highlight the previous problem that we did with the multiplication for part D. And this just to show you guys another way to how to use your calculator. Once it got selected up there, I just went ahead and press enter, and it brought down to the bottom. Okay. If you cannot, you guys, it's too difficult for you guys to do this way, it's fine. You can do it individually. I'm just gonna change the multiplication to a addition. Add here and move it right here. Do a plus, and then I'm gonna press enter. That gave me 139. So up here on the top is 139. And then I'm going to do a division divided by the 139 with 30 combination 6. Okay. Something is not right here. Oh, I know what they're wrong. My bad, guys. Right here. This bottle of 6. I need to adjust my numbers here. My bad. That means 6. Let me. Here goes. That meant choose 6. My bad. Okay. Choose 6. There it goes. Yes. Yeah, got it. If 6 bottles are randomly selected, what is the probability that all of them are in the same variety? So I'm choosing 6 from, hopefully choosing 6 from each of them individually. And what what's the probability of choosing 6 in the, from any of these groups with a total of 6 being chosen, which is right here. And that's where the plus comes in, because we're choosing 6 from each of those individual groups. And my bad, there's supposed to be 6, right? Hopefully you guys have lasted up to this point so you guys can see my mistake. If that's the case now, again, just for purposing of practicing using the calculator, I'm going to go up here and highlight that, press enter. It gets highlighted by itself, by the way. Press enter, and now I'm going to choose the number 2. Change the 2 to 6. That becomes 6. I just put the blinker on top of the 2, tap in 6, one more, 6, enter. Alright, this number gets changed. Number becomes now 1162, and then if I divide it by 30 combination, choose 6, get that's better. Okay, cool. So 30 combination 6 gives us 0.001957. Excuse me. And that's the answer for part E. Alright guys, well, that's it. Hopefully I haven't confused anybody, and hopefully I was able to help somebody with these problems. Thanks for watching the video. Please don't forget to check the description for more information about where you can follow me, how to support me, and also the timestamps.